record, yeah. Perfect. Thanks.
Okay. Okay, so that's the reminder there. Then a little bit about what DClare for MPS is. DClare for MPS is a bunch of open source projects, or DClare is a bunch of open source projects, and one of them is DClare for MPS. You can find it on GitHub with this URL, and it's under development. Although DClare for MPS is probably the most mature, already used by customers part of it. It exists of a immutable collection framework. It's all written in Java. It's DClare, which is an engine. Is an engine, a kind of invariance engine that solves constraints for you on models or on structures in general. There is an extension to that so that you can easily write those constraint-based specifications in Java. And there is also an integration in MPS so that you can easily apply those rules or constraints to modeling languages. And we plan, or actually we have built also a provide EMF integration, but it needs to be ported to the newest version and to be open sourced. So this is also work, if people are interested, that we can do. The advantage of this is that you can also use those different technologies together because they have an underlying conceptual, structural view on the world, and you can transform one technology to the other technology. So it's a kind of plugin structure that you can use for EMF and for MPS and for other Java-based environments. And we're also going to participate with open source organization that builds projection editors for the web. It's not imperative language. No, the engine is actually kind of a virtual machine for declarative rule-based language. It's like Excel. You just state what you want to be, what always should be the case, and automatically the system will take care that it will be so. So it's rule-based, it's declarative, it's reactive, but implicitly reactive. So it's not a reactive framework, but the constraints that you define are automatically kept same, and the system will automatically react to changes. And it's incremental, meaning it will do the minimum amount of changes to get all the rules hold again. The idea about DClare is, from our experience, that there are many DSLs, also meta DSLs for defining the DSLs themselves. And they normally do not write, they combine not really nicely together on a semantical level. Because if you do code generation, then you, for example, to give it a semantics in an imperative language, who guarantees that all those different aspects like type checking and scoping and that kind of stuff work together, and the generator and all that stuff. So it's a kind of underlying formalism, and if you reduce to that formalism, everything fits nicely semantically together. That's the idea behind it. So instead of the problem, we have a nice integration in a declarative language. So this is the goal that we strive for. Let's just go and demo it. Okay, so here we have MPS, and I prepared a pure MPS example without any transformations yet. So it's we're going to build that. The idea is we have a very, very simple language. It defines containers and elements, and containers and elements can have names, and they can be nested, of course. The elements are contained by the container, and we have so-called source containers and target containers. And here you see an example and we can add elements. This is just MPS projectional editing. I just prepared it as a very simple example. And the whole goal of this, of course, is that if I add an element, then on the right side, the target should also add an element. So we are going to build a transformation that transforms this into the other concepts, as they are called classes. Would have you called in EMF. They can be part of different languages or in the same language. It's the same thing. Yeah? Whether you do a transformation within a model, portions of the model, or across different models, conceptually and technically, it's the same thing. Yeah? So both are possible, but I did it very simple and small, so I do it within one model. Yeah? So what do we want to do? We want to translate a source container into a target container. Now, here the language is defined. Here the structural aspect of that language is defined. I will just close the other stuff. Source container, and we want to generate a target container. Now, for that, we can create a rule set and define an attributes, and this is more or less the language of MPS, base language, and we want to have a target container for the, let's call it target, and let's create a so-called light quotation. This is a way to define objects of a certain concept in MPS. The target container. The target container, of course, has a name. The name should be equal to the name of myself. Let's just keep it like this. So we have a target container, but now we still have to define where that target container should be placed. And we see here that this target container is in the same model as its source container. So this is what I want, this example. So that's what I'm going to define. For that, I need a rule set that works on model level. And then I can say rule this roots, the roots elements in the model. This is all base language of MPS. My target containers are equal to this, the roots, my source container, but then the target of that. So here I state that within the model, for each source container, there is a target, which I've defined in the other rule set, that's this one. And that should also be part of the model.
Wim, can I ask a question?
Of course.
So basically, at least in my understanding, so DClare is here defined in terms of MPS itself. Or I mean so the language you use, so yeah. the rules and I mean this stuff. This is MPS. So it is MPS, right?
Well, this is an extension. No, well, rule set is a language defined in MPS that is translated into Java, which is executed by the DClare engine. But the rule language itself is an extension of the base language of MPS.
So exactly. So I mean, the transformation language is entirely embedded in MPS. So it's not external. Nothing is external now, except then how you translate stuff. But I mean, the syntax.
Exactly. So what we did here, this is the DClare. This is what we call aspects of a language in that MPS construct. So you define a language and you have different aspects of the language, the structures, the editors, the constraints, the behavior, your type system, your generator, etc. And we just added an extra flavor to that.
Yeah.
So it's a meta language defined in MPS itself, and it's called rules, and you can define constraints on those models. And with those constraints, you can define transformations or arbitrary other, like type checking or transformations to other languages or constraints or validations or whatever. But
so when do you do this for eCore?
If there is a demand within this project to do so, we will do so.
We can. I mean, I see a very nice opportunity to actually, because this is. I mean,
but actually, I'm very glad that you are enthusiastic. But shall I first?
Yeah, continue.
Take the steps.
Sorry. Yes.
Because perhaps you find different when I continue. But your notion is correct. What we do is we didn't create a language for defining transformations. We created an engine that can be combined with arbitrary other technologies.
Yes.
And within those technologies, we are creating languages which fits to that environment, to that community, so that they can write it in a more natural way. And so, and I think that should be the approach, because otherwise, well, it doesn't work. It should be integrated from that language perspective.
Yeah.
So a DSL is not usable in an absolute sense, but always relative within the context of its users. And so that's how we should do it. That's our approach.
Good.
Okay. So in the meantime, I've compiled it, and you see that automatically. This is also nice. So it's not only doing it on the fly, but it also repairs it when the rules become active again if you compile it. So it can incrementally define the rules, and they are automatically applied on the models. And you can see we have these extra targets here. We didn't have the target for B. I didn't know if you noticed, but still we have elements over here. So now I can create a new source target, and then automatically, and we see the names. You see, this is just lively. And if I remove the target again, other way, it should be removed. This is I hate this. It should be should also be the oh no. Okay. I removed the target, and I didn't define it in the other way around. Yeah. So we only defined a rule that defines the source to the target, and not in the other way around. So that means that if I change my target name, for example, I'm not allowed to, because I've defined a rule that derived that name from the source. So if you define something in one direction, it will prevent you from changing it on the target side, because that rule should always be true. So it's guaranteed that all the things that you state in those rules, and you can also make conditional rules if you want to differ from that, but everything that you define should always be true, and the system guarantees that. I want two things to be added. I want those elements to be synchronized. Let's first do that. So we have those source, and I can define the elements, and then I need and then elements, and then of course I don't have something yet, so I need also to define how I translate a source element to a target element. Okay, and then I can define. You can also see that within MPS you can switch. If you focus on a certain concept, you can switch between the different aspects. And here we see our rule aspect as just one of the aspects. And these are aspects which are defined in MPS. I didn't create it, so it's just part of the whole idea. And so now I have a target here. So if I now
and Wim, what do the other aspects show?
Well, but then I'm going to give you an MPS course.
Okay, yeah, sure.
So this is a definition of the editor.
Yeah.
So that's the one that we see here. So this is a source container. You can see that this is an instance of that editor. So it's a projectional editor specification.
Okay.
You can also define constraints and behaviors, but many of those things can be replaced by rules which are more incrementally behaving. So it's not really very interesting. And you have a type system and scoping. And scoping is probably more important within the, but there's no, in this example, it's not that excited. You can also define generators to other languages, but those do not work incrementally. You have to run them and run them again if you change something. And if you build them using DClare, they automatically translated from one to the other and they kept in sync. So that's the difference. So this is incremental, immediate, reactive behavior. So if you require that, then you can use rules. That's the idea. Okay, so we have created the elements. Now we can see that the target indeed, here is the element. Let's get it up here. Here a source. Now we can. So now it works nicely 2 directions. Yeah. Okay. Oh, in one direction, but it also implies the. Now within DClare, although we can build syntactical sugar to make it symmetrically if we would like, but I didn't do that. So what I did on purpose is you can just write a transformation in the other way around, and they will find each other, because a lot of times you only can translate a portion of it. And in this way, you can exactly tune, but they should be consistent, which portions of your language are translated into the other language and the other way around. But it should be consistent from a cyclic point of view, of course, because otherwise you will run into, because the rules will never become true, because you will translate into something different than your source again. So it's that way. In this case, it's very simple. We can do it the other way around. We have a target container. Comes a little bit dull, of course, now. Of course, it's a source container. Let's call it source. So you can see these attributes as a kind of non-persistent references that keep the elements that you translate into each other connected. But they are not persistent. So if you stop the engine, or you stop the session and you start up again, the models will find each other because of the constraints and reconnect. So you don't have to persist your translations between them, if you understand what I mean. It does pattern matching, and if the two are for those portions which are correctly connected to each other, it will automatically reconnect. And this is very nice, because if you do things like version control updates or these kind of things, you need to restart your system. You need to reconnect to those worlds. So you can build your model, I can build my model, and then at some point in time we can say, let's synchronize. And then that's the idea.
Wim, I have a question.
Yeah.
So of course now you said, I mean, you're showing a simple example. So I'm wondering now one thing. So how? Yeah. So imagine that you have a little bit more complex language in which you have, instead of having container A, you have containers or whatever, blah blah. So you can have in one model you can have several containers with their names and with their elements, and you want to have a rule that puts in relation only containers with a certain name and only elements with a certain name within those containers. So no matter, will this work? So no matter how their positioning within the model, I guess, all right?
Yeah. It doesn't matter. So you can make it arbitrarily complex.
Yeah.
And I will show an example later on. Yeah, but the problem is if I start with that example, you get drowned. So I just want to get a feeling of your.
No. Yeah, sure.
Yeah.
I'm not.
I
don't want to see it. I just want to know if it's possible.
The challenge
I already have it. I already have it in front of me. So.
So the challenge is, of course, how do I it is always tricky if you have two languages with structural conflicts, and I will show one briefly later on. Then you want to define it in two directions. Then that's tricky. Yeah. So and that is always no matter how simple your transformation language is, mentally that is something that you need to work upon.
Yes.
And the system helps you, because if you do something which is inconsistent, it will give you an error and say, well, these two rules cannot be combined because they are running infinitely and changing this into that and that into this. And in this way, you can just define it in one side, then in the other side, see if they are the same, and then connect both of them together. And in this way, evolve to a bidirectional transformation. That's the work that you can do. But that's the idea behind this. Let me just it's difficult to talk and to write at the same time. Source. Okay, now can I do source. So if I now rebuild the system, then I have a problem. Why do I have a problem? It says, well, you have here we have a source, but it's a orphan. Yeah? So we didn't define yet how those sources will be put into the model. So this gives you, if you define a partial transformation and something doesn't have an ancestor, you get a message, you can click to your rule that causes the problem or misses, and then you can just repair it. And in this case, it's just the inverse of what we have defined over here. Because for each target container, there should also be a source. And now we are complete, we built. And if we come now to our example here, then I can, of course, what we did before here, but I can also do it here. Make sense?
Yes.
So it's the other way around. Yeah? You don't see that probably because you don't know where I'm typing. But that's you have.
Oh, we see your cursor.
No, we see it.
Okay. So I think this makes clear, and there are two semantical rules here. It's called ripple out semantics. So if you change something, then it will not be changed back until other rules that do not change that back are executed. Which means that it ripple outs, if you understand what I mean. So if I change it on the left side, in this case, it will change on the right side and vice versa. So you define cyclic rules and they ripple out. That's one semantical aspect. The other semantical aspect is that if we define these kinds of quotations, as you can see over here, then it's not really creating a new object, but it's creating a kind of placeholder and tries to search based on the other constraints how those relate to the other ones, and then came to the conclusion that it's the same thing. So there's a kind of pattern matching in place here. Otherwise, we will have infinitely new objects. And though these two concepts together, you can use for defining arbitrary transformations in arbitrary many directions and connections. That's the idea of DClare.
And I guess that there you can, of course, you can change the name, right, of the target. So if you want to give it another name.
Let's do it like this. Let's make this lowercase, but then we have a problem because I do that. No, in this case we don't have a problem.
Because you're
but let's go to the other side. And so if we have the source
the target
elements. I'm sorry. Yeah. Understand? Make. So if I now close these two. Oh, I see that I've created an error somewhere. What does it say? Oh, yeah. Oh, these things are. Oh, that's a pity. That's strange. Why doesn't it work? Okay, source element to lowercase. Yeah. Of course, what I need to fix it, but you can see now that it's different, but it's symmetrically, so they can find each other again. If I stop it and start it, then yeah. This is. Shall I show a slightly more complex example?
Yeah.
Yes, please. I would like to see something not symmetric.
Sorry?
I would like to see something which is not symmetric from a model point of view.
Yeah. Well, it depends on what you mean by symmetric. So
yeah, I mean symmetric. I mean structurally.
Structural conflict. Yeah. I will do a simple one, but still complex because the structure is completely different. Yeah. I must warn you, it only works in one direction, although it does partly in two directions.
Yeah. Yes.
So, but it could be theoretically possible to do it in two directions, but I didn't have the time to prepare it.
Yeah, sure.
So that you need to see that another time. I will start that example.
But I still think that we should look into doing this for eCore. Because this is actually something that I've been thinking about for some time. Actually, I was working on using UML action languages as a transformation language for UML itself, which is something quite close to this, even though a bit more painful. So I stopped doing that.
Well, the semantics is really tricky. Huh?
Yeah.
So, but here you see another example, and perhaps it looks simple, but it actually isn't. There are actually two languages here. On the right side, you see an object-oriented language, which has classes with fields. On the left side, it's a fact-based modeling language. It's a language that we use. This book is about fact-based modeling, and that's what they use with the tax office. It's typically Dutch and Australian modeling language, and they define facts. And those facts, as you can see here, they define a relationship between the object types that you define over here. Yeah? However, if you translate it into an object-oriented MOF-like structure, in MOF you have the opposite construction, then you will have fields with similar name, where the other one is the opposite from the other field. And these fields are contained by the class, and these facts types are contained by the model. So this is a structural conflict, and you need to turn the model inside out, if you understand what I mean, and keep it consistent. And the change on one side can be a move on another side. So that's the idea. So if I switch this, for example, then you see that my field is moving. Back again. Create a new one. Nothing happens. You see, I have an inconsistent model, but nothing happened yet because there's no relationship with one of the fields. But if I create it here, then you see it over here. Again, you see it's incomplete because I don't have the complete information here, but I can fill it over here. And then I can say, for example, this should be text, which is a primitive type, which is in this case translated into string, because it's a kind of Java-like language. And so it doesn't have an opposite because this is a primitive one. So this is an example of something which is slightly more complex. I don't know if you, let's see what I can show you here. No, this is the role. This is the role. And here we have the OO part, which is a field, which is only created if it has an opposite. And its opposite is non-lexical, meaning it is a complex type. And then the opposite of this one is the opposite, and then it's OO, whether it's many or not, and the object type, and therefore it's OO. So this is a way that you can solve these kinds of issues. You can also define structs with arbitrary identity to really do complex stuff. For example, just to be fun, oh, no, that's not what I want. Sorry. You see this? So this is a rule that defines Sudoku rules. And it solves a simple Sudoku for you. This is not a good fit. This one is. But also, if you want to change the size of the Sudoku, then you can do so. So it's also in-place transformations, if you like. Then it's back again. So you can also see that just a number can have an effect on your model. It's anything to anything, if you understand, as long as it is consistent. And also the solution rules are defined in MPS, so in rules. So they do just a reduction on the rules of Sudoku. And so the amount of possible values shrinks because you have defined that can only be possible as a kind of subset, and that is a cyclic rule. So it reduces to something that is either a conflict or it has exactly one value for each cell, or it's undefined, and then you have a white undecided, and you have a white thing. So this is also defined using rules. Yeah. So it's almost a kind of reasoning engine, but it doesn't have the extent like Prolog or something like that, but it does a lot of for you. For example, if you want to balance a tree, then you only have to define like operator ordering of a tree, of operators, binary operators, then you only need to have the operator precedence and one branch in the tree, and you can just flip them, if you understand what I mean. Just if the order is in the other way around, because the whole system will reorder automatically, because that is the semantics of the rules. They will trigger until the fixed point is reached, and the fixed point is when all the rules hold. No conflicts are there anymore. So ordering, sorting, restructuring can all be done. These are kind of, that's what you call in-place transformations. That's what I wanted to show you.
Awesome. Thank you very much for that, Wim.
It's open source. Examples are also open source.
Yeah. Now we just need to figure out how to bring it to the Eclipse world, right?
Wim, do you have where can we find the specification of the of the language? I mean, not on the specific. If it exists, not on the specific implementation, but on the on the DClare conceptual language itself. So on the engine.
The biggest weakness that we have is we have almost zero documentation.
So you are our manual.
Yeah, and so we have examples. We have examples to the rescue, but I'm working on that. But actually, it's worthwhile to do that as a kind of a paper, because of the ripple out semantics and the identity matching. Because you need those two ingredients, and those are non-trivial. So non-trivial from the point of implementation, but conceptually they are well defined.
They're well defined, but they're not written anywhere.
No, they are well defined in my head.
In your head. Okay, that's good. No, because I was wondering one thing when thinking about bringing this to to EMF, whether actually if it will actually be possible to take it and just bring it there, or whether some actually semantic changes will be needed to make it work in that world.
Yeah, I can answer that question because I know both, and I did it before, but then with an old version of DClare, and this one is more sophisticated. In pure DClare, identity is fixed, and you do not have implicit identity, but explicit identity. And this makes it very easy to define transformations, because you don't create objects, you just postulate the object with a certain identity, and then it's the same as somewhere else. However, in object orientation, and that also counts for MPS structures model, but also for EMF, the object semantics is implicit identity. If you do a new, you always have a new object. So you need those identity resolvements, semantics, and that is tricky, and that's something we done for MPS. We still have to do that for EMF. But for the rest, for the ripple out semantics, it's exactly
the same. It should be the same,
yeah.
Well, that was really interesting. So maybe we can have a separate chat about
I like
these semantics and stuff. I'm very interested in that. So
I think we also need a discussion at one point where in the technology stack this would fit for Bumble. I think I see several areas where this might be really interesting, but I think this should be part of the conversation that we're going to have in that second workshop.
But I started the presentation with the perfect fit, if you understand what I mean. So to define model AST to AST transformation, this is a perfect fit. So this is the thing which you have almost out of the box for MPS, but if we build for EMF, you also have it for EMF. So that's but if you connect concrete syntaxes, you're very much. We have done so, by the way. We have a complete workbench language based on completely declarative, but it's really immature. But it's possible. We have even ported swing completely to it. So it's but that's still under development. But so I think from a perspective of abstract syntax to concrete syntax, it very much depends on your technology whether it's a fit or not. Because MPS already has solved that, for example. And if we would replace that, we would actually replace MPS. It doesn't make sense for a lot of our use cases. So that's why it's a good fit for the incremental transformations within it. The other thing that we're doing is we already implemented that for MPS, but I didn't demo it. We can do that the next time. Is that we have remote connection. So if you have a connection with DClare, then you can connect it to any other DClare node which shares the same meta model, and then it synchronizes over the network. So then you can have live Google Docs like connection between any MPS node for that portion of the model which you have decided to do so. Mm-hmm. So that's another addition that we have created. So there is a relationship between those two, and we have solved that. So these are the things that we have. We are maturizing those technologies already, and we're going to do that anyhow. So of course, I would very much like to do that as being part of the Bumble project.
Yes.
It goes without saying.
Okay, thank you again very much, Wim, for your, as always, insightful and very inspiring and interesting